So welcome everybody to our session on effective computational intelligence in industry. I'm so happy to introduce you to Sharon Matthews and Bryce Murray, both of whom are members of the Society, of the IEEE Computational Intelligence Society. They're here to tell you a little bit about their journeys, their paths, what they're up to now, and where they see themselves in the future. And hopefully to offer you some advice. So without ado, I'm going to let Sharon give you a few facts about herself, and then we'll turn it over to Bryce.
Sure. I think, hi everyone. My name is Sharon Matthews, and I'm currently a principal research scientist at US Bank. And I'm happy to share my experience throughout my journey, my career journey. So probably I have like few slides kind of going through my career profile. Feel free to drop in questions if you have any specific ones throughout my journey, and I'll be happy to answer as we go through.
Yeah, and I'm Bryce. I've been in industry, I guess, for a year. I graduated from Mizzou, about a year ago. So it's been a learning experience, to say the least, to see what it's like to be out of academia and in the real world, working with real data. It's been exciting. It's been good trying to synthesize everything that's happened over the last year and condense it down to like, what are the biggest things I would want to know? What are the biggest things I've learned and the biggest things I'm struggling with still to this day, moving forward and understanding how to do this, because it's a learning experience for all of us. It's shifting regardless of the pandemic. It was challenging to even figure out, what does it mean to be a data scientist? What does it mean to be an AI engineer? And so hopefully, listen to us talk, you'll get an idea of what it's like to be out of academia and in the real world and the challenges that we're facing.
Okay, thank you very much both. And just a few pointers before we get into our conversation. Just want to make sure that you do get the best experience from this session, and that usually means technical issues. So please be sure to be using a desktop or laptop computer. It's a much better experience over a phone or iPad device. Please use earphones or headphones. And a fast internet connection is much advised. Ethernet would be, wired connection is the best way to go. Please close any other applications that you may have or browser tabs. Please disconnect from any VPNs as that does cause issues as well. Chrome and Firefox will offer you the best browsing experience. And one last note, if you do have questions, and I do expect this to be very conversational in its in the session today, please add them to the chat, which you can see on the right-hand side of your screen, or in the Q&A. And we will be sure to get it to as many questions as we can. So with that, I am now going to share my screen so that we can take a look at the slides that Sharon has prepared for you. So please just give me 1 second and I shall pull them up. Okay, and you should all see my slides now.
Okay. Do you want to go first? I think
I have yours up, Dr. Matthews.
Oh, is this mine?
Yes.
These look like mine.
Oh.
I'm happy to go first, though.
Okay, on my screen it looks like yours, so I apologize.
Either way is fine, yeah.
One second, I apologize profusely.
Yeah, but over in the chat, I'm interested to see what your research interests are. So what y'all's backgrounds? I know we have a wide range of engineers here.
Yep.
Oh, there
Do we now have the correct slides up?
Yes, these are mine.
Perfect.
All right. Hey, everybody. I introduced myself just a second ago. My name is Bryce Murray. I work with a consultant, or what's used to be a consulting firm called Aperio. They traditionally have done behavioral science in the workplace. I was one of the first hires for this organization. I was the first hire that does anything with data or engineering. And so it's been a very unique experience, different than what I would have thought I was doing a few years ago. but it's been really fun. It's been really exciting getting to work with a different style of person, getting to work with people that are non-technical, that are domain experts. And I've listened to a few of the talks today, and one of the things that just seems to be a trend is this is a group of technical people, but most of the talks have focused on something slightly non-technical, which has been I think is going to be a trend as we're talking about industry, is most of the time organizations and workplaces are wanting not just, you to be a really good problem solver, you to know how to connect that solution to a problem, but it's more of the soft skills that are really driving a lot of the high performers in any engineering. So we'll go ahead and get started. Stacey, if you want to click the next slide. I'm going to start a little bit about me. So I'm from South Mississippi. I grew up working on the farm. Completely different background than I'd say a lot of engineers. But is there really a set path for your background as an engineer? Probably not. We each have our different experiences that kind of lead to why we do what we did. And so after I graduated high school, ended up going to, can you click the next slide? A little college in the middle of Mississippi called Mississippi College, where I got as far away from farmland as I could and started studying computers. But John Deere, in the previous session showed us that that's rapidly changing. And so I studied computer science, physics, and math. And then on the next slide, I went to a university called Mississippi State University, where I thought I was going to be building drones and helping farmers. And that was not the case at all. I ended up hating hardware and actually liked the software side of things. I liked the applied math that was going into the algorithms that were being developed. And this is actually where I found out about computational intelligence for the first time. It was something I didn't have a clue of what it was, and we'll talk about that in just a second. But it was just a great experience. It gave me a breadth of knowledge across a lot of different fields, even related to computer engineering. I met a professor that I really liked, and he ended up going to the University of Missouri. If you can click on to the next slide. And I followed him up. So Dr. Anderson invited me to come up, and working with Dr. Anderson was never a dull moment. We had a lot of different projects that we were working on. So I highlight a few of them over here with icons on the right. So we worked with the Army, where we did a variety of computer vision projects. We worked, I got back to the drones actually, where we worked with NIJ and some forensic anthropologists to develop algorithms that were going and searching for missing people, which was a fun and unique experience. And then lastly, I did actually get back to a little bit of agriculture, where we did a handful of projects, some with the USDA and then some which were just more exploratory in nature. How do we partner with our ag scientists to actually produce value from the data that they're collecting? And so that's really kind of sums up the research I did over probably 6 to 7 years. But one of the biggest takeaways, again, which I mentioned just a second ago, was on the computational intelligence side. I didn't know what computational intelligence was. I didn't know what pattern recognition was. On TV, they would talk about data mining, or they would talk about AI, or all these things that seemed very abstract. I didn't really know what they were. So it was good to really connect a few dots and get in a few classes that really highlighted the difference between what's just a basic, automation. How do you go about solving this simple problem, to what are the algorithms and where they come from? What's the algorithm story? And that's something that computational intelligence has been really good at. So if you can go to the next slide. I want to just kind of highlight what computational intelligence is, or the three main categories of it. Over in the chat, can we just get a show of hands or something? How many people in the room have actually heard of computational intelligence? And so if y'all want to say yes or no, that's great. I'm just going to go ahead and explain what it is. Perfect. I see lots of thumbs up and a few no's. So you'll have a little bit of a takeaway today. So computational intelligence is a set of multiple algorithms, multiple theories, and applications associated with those. But there's three main branches to computational intelligence. There's neural networks, which I'm sure everybody has heard of, evolutionary computation, and fuzzy sets. I had to find good logos to go with this. The fuzzy one was really the hardest, so I'm going to try to brand fuzzy sets as a bear. So if y'all can just stick with me on that. And so it was really good to just kind of see that these algorithms were all unique and all founded in some type of theory that went beyond just an algorithm. One of the things that I'm often asked in industry is, well, what applications do these things solve? And so it's really challenging to answer that question because there's a lot of overlap in each of these. And so in just a second, I'll show you the product that we've built that actually uses each one of these at some capacity. So drop down one more slide for me. And so I give the quick definition for what each of these is. You can go to the IEEE CIS website and look for the what is CIS, and it'll give you these definitions. But basically, neural networks has been inspired by the brain. It tries to model the neural networks that exist in our heads. Evolutionary computation uses biologic evolution as a source of inspiration. So you can think about how genetics work, how we propagate that genetic material through each one of generations, whatever species you're talking about. And the last one's gonna be the fuzzy logic. And so fuzzy logic was meant to model the human language as a source of inspiration, the fuzzy systems, model linguistics, and the imprecision of working in the, real data tends to be imprecise and uncertain. So how do we connect what happens in a lab, which is very controlled, to something that's maybe a little bit fuzzier? If you can go to the next slide, please. So during my time in academia, one of the things that I really was, glad to be part of was the CIS Society. That's who, I'm sure you're here talking about today. Some of the opportunities that exist within this community, you're being able to go to conferences where you're able to connect with, people kind of like you that come from a wide variety of fields. And so this was a group of us at New Orleans a few years ago that came together for the IEEE conference. And a lot of these people are just really smart, and I still have pretty good connections with all of them. And one of the benefits of it was that it was in person. So we got to sit down and have a meal, like even Terrence was talking about in his talk, where you can get to know the other person and you can get to see what their passions are. And just about everybody in this picture, I think I was able to connect with and understand what they're researching and get to dive into it and get to talk to it. And even today, if I called them up, it'd be, hey, let's get together and have a cup of coffee and figure out what's going on, which is just something that was different than even my undergrad experience, which I was parts of organizations there. But this one it's more of a personal connection for things that aren't necessarily mandatory, which is pretty cool. So if you can go to the next slide. So as my time in academia was wrapping up, I came to the crossroads of, is it going to be academia or is it going to be industry? That's always the question you're asked as you're kind of getting to the end of your academic career. And so I decided to go the industry route. And so if you can go to the next slide. And so actually the next slide too. So once I chose industry, I don't really know, it's kind of confusing to what that means. And so a couple of months ago, I was able to be a part of a committee that the IEEE CIS has for industry and government relations. And so as I'm scrolling through the names on the list, there was a few different companies pop up, and I looked at each of them. And this is where I realized that industry is not all the same. No two companies are the same. And this really puts it into perspective for me. I looked to see the number of employees that Siemens has, and they have 303,000 employees. That's a lot of people. There's a much different experience, a much different culture in an organization like that versus the one at Aperio, which is where I am, and I was really the third and fourth hire. And so I just wanted to contextualize this a little bit more, and so I looked into just how can I make this point that these two things are so much different, that my perspective is not going to be the same as a Siemens relevant. So if you can go to the next slide, I tried to find just a good comparison. And so if you look at just the weight of these two animals, it would be like Siemens is this African bush elephant, and then Aperio, the company I work at, is this little bitty chick that can almost fit the size of your hands. And so it's just obvious to me that whenever I was in academia, as we start talking about industry, it all kind of gets convoluted and thrown together like everything is the same, and it's not. And so this is one of the biggest takeaways, is if you're getting ready to go into industry, if you're getting ready to get out of academia, know where you're going, know what you're getting into, because these two experiences are going to be completely different. And one of the main ways, if you can go to the next slide, is that whenever you're working on a data science team, a data analyst team, AI science team, whatever you want to call it, data AI world, the hat that you're going to be wearing is likely going to be different if you're on a team that is with a large company versus one that's in a small company. And so this is a good framework that I've found for breaking down data science teams. it breaks it down to 7 different roles. And so in a large organization, it's likely that you'll only be wearing one of these hats, and you may even have multiple people that are all wearing the same hat. Each of these is tough in its own way, and it's hard to find somebody that can do all of them. And so at a small organization, like Aperio, you can go to the next slide. The hats that I typically wear are going to be a combination of the ones in green. So usually like the project manager gets split between a few of us, but the primary ones I'm going to wear are going to be, oops, and I left out machine learning engineer, are going to be the data analyst, the machine learning engineer, data architect, data engineer, and data visualization expert. One of the takeaways from this is that the pieces that are really domain specific, like the business analyst and the data journalist, those two require a pretty high level of domain knowledge to be able to connect your solution to a real world problem. And those are really hard skills to really master. So especially whenever you're coming from such an academic world. So if you can go to the next slide. So this was my team at NU. We were a group of engineers, and we all pretty much had the same behavioral profile. I'll expand on that in just a second. But what's been interesting is that we all think alike. We are all basically have the same perspective. And whenever you go to a smaller organization, that's not going to be the case. And so the organization I work with, we do behavioral science in the workplace. So one of the things that we do is we work through different psychometric tools, which is almost like a personality assessment. And I'm gonna give you a quick breakdown of mine. You go to the next slide. It breaks it down into 4 different data points. And I can just about guarantee that everybody in this group has a very similar profile to mine. We're all gonna be communicating the same way, probably have roughly the same like values and perspective whenever we're building something out. My biggest transition has been how to go from something where we're all in the same perspective, being able to communicate and collaborate with those that are different than me. And so if you can go to the next slide. Now I work with a team of behavioral scientists, and it would take hours just to go through the differences of everybody in this picture, but I'm the only technical person on staff and the only one that has anything close to that, kind of the spectrum of behavioral profiles that we looked at just a second ago. And so if you can go to the next slide, I want to describe our Aperio's path. So we are now like a product-led company. We're working with customers to find their problems so that we can develop solutions. And usually these solutions are a little bit more, I like to think that they're a little bit more complex because we're having to really communicate the insights of data to the person. One of the biggest things that we find is how do you let somebody that's not a technical person understand the insights behind the data? And so we're less about just data processing, and we're more about how do we effectively communicate that data so that somebody uses it. We don't want to build an algorithm that's never used, that's never giving good insights, or even worse, giving good insights, but they're just misunderstood, and so they're not driving decisions. And so our kind of workflow is we're finding customers, we're working with them to identify their gaps, building them an effective solution, and then working to create a product out of that that's scalable to a different set of people that are having the same problem. And so if you can go over the next slide, we've done this on a few occasions, but the main driver behind this, this is really the only technical slide I have in my whole presentation, uses fuzzy logic, neural networks, and evolutionary computation to find the set of fuzzy rules that are driving some type of decision, I guess. And so specifically, we've built this product around this algorithm and a set of psychometric data for entrepreneurs. And so we have this product called Halo where we have linked the psychometrics to successful startup founders, meaning that we can identify the habits that startup founders need to have in order to run a successful business. And so in this case, you can see the green and the red. So the green would indicate, hey, if the person falls in this range, then they are, they have the right amount of this, trait. But if they're in the red, then a little bit of work may need to be done in order to set them up for success. This has been done before. This is not new. What's new is being able to communicate those insights to our domain experts. So for instance, if we just have a classification algorithm and it just spits out, yes, this person has the aptitude for success in an entrepreneurial role, that does us no good. Um, what we really needed was we needed to know what features were driving that decision and why. Because when we turn that information over, now we can give that to a behavioral scientist and they can say, okay, well, this person, their perseverance was a little bit too high, which leads them to being stubborn. And if they're stubborn, then they're likely going to stay on the path too long, which is part of my behavioral profile. I tend to be stubborn. And so knowing that information, I can now check myself to say, okay, am I just being stubborn here, or do we need to keep persisting down this path? And so being able to identify that is really practical for our behavioral scientists. So on the next slide, this is just kind of a screen grab of what it is, what it looks like to take an algorithm, which honestly didn't even take that long to build and actually build a product out of it. It's really complicated. It's really hard. We don't have software engineers. We don't have web developers. But over the last year, we've actually been able to operationalize this computational intelligence framework so that it's providing actionable intelligence for early stage investors and for our founders. And so if you can go to the next slide, the three big takeaways I have or what I've learned in industry are going to be that real world data sets are messy. I've learned through a series of trial and error that some of your typical algorithms, even the ones that are in the open source frameworks that are just widely used, don't always play well with real world data. There's assumptions that we make whenever we're building out theory that doesn't always apply over to real world. And actually fuzzy logic has been one of the driving forces to handle this. I could talk about that for a long time. The other one is a soft skill. So projects die in isolation. Every time I tried to do something independently and wasn't communicating to the people that needed to be in the room at the right time, the projects failed. I went down, told you I was stubborn. I went down the wrong path whenever we were first developing Halo for like 3 months, only to find out that we had to start all the way over. And starting over was the right move. We brought the right people in the room, and now we have a successful product. And the last one kind of hit something Terrence said during the keynote was finding what's important to you. Like what's driving your inspiration? Why are you showing up? What is it that you're looking to do? Even on the solution side, as you're building out solutions, it's likely if you're not working with technical people that they don't know what the possibilities are. They're going to be looking for you for advice. They're going to be looking to you for to know what's possible. And so understanding what's important to you will drive likely the projects that you'll be working on. And so lastly, on the last slide, my biggest takeaways are discover your interest and then understand the importance of emotional intelligence. Know when it's the right time to bring those people in the room. Understand that everybody on your team is there for the same reason. Like they're there to make the business better. They're there to make the organization better. And so finding that common ground with them is worth its weight in dividends to know how to impact for a larger purpose. And then last slide is going to be on the CIS committee. I got involved in it when I was at Mississippi State. I think that it's had a huge impact, even like events for today, being able to come back and talk about my experience in industry, staying connected with people that are like-minded and are going to run into technical issues, especially when you're on a smaller team. While most of the big struggles I've had this year aren't technical, when you're working on a small team, you don't have anybody technical to bounce stuff off of. So having that network and finding that network inside a like-minded group of people is nice for promoting everything you need. All right, and that's all I got.
Great, thanks, Bryce. And now I am going to share the other presentation. So if everybody will just hang tight for 2 seconds, I'll bring that up. Okay, and take it away, Dr. Matthews.
Great. Thank you. Great presentation, Bryce. I think good to know your journey and actually saw your whole career path so far with learning from CIS. So I think it was great, insightful to know that. So hi, everyone. My name is Sharon Matthews. I am currently a principal research scientist and chief digital officer at US Bank. If you can go to the next slide, you'll kind of see how I navigated, I guess, an overview about me. So, in terms of my background, I have a PhD and master's in electrical and computer engineering. And my focus areas have been machine learning, deep learning with applications to computer vision, mainly during my PhD. And later, I was part of Intel Security McAfee, where I was looking at how these technologies like deep learning or machine learning could be applied in the security area. So you would see my papers or projects related to ransomware detection, steganography, explainability, and even work on things like deepfake. So and then I mean I think I have been fortunate to have that experience of applying technologies like this in many industries, be it security, computer vision, even biomedical domain. And my PhD thesis was mainly looking at the computer vision domain, where I was developing core, I would say, novel deep learning algorithms and dictionary learning algorithms specifically for ECG classification, and even like recognizing the activity with a person who's wearing a wearable sensor, something very similar to a smartwatch. What kind of activity the person is doing? That was like my PhD thesis, and then I moved out, and once I completed my PhD thesis, I moved in the industry, and I can kind of walk you through my experience there. So throughout my journey, I think it's been roughly 6 to 7 years. I have 12 to 13 publications and 12 approved patents. So I think I've been really fortunate to do that so far, and I have been giving industry talks as well in top industry conference like RSA. And additionally, I have been contributing to the academia as well, where I'm presenting at AAAI or EWF and conferences like that. So I think now the point comes to the fact that have you ever kind of had those moments when you kind of stop back and look back and kind of understand how did you get here, right? Like to kind of navigate my whole chart, maybe next slide, you can actually see that I was born in Bombay, and Bombay is known, Bombay or Mumbai, however you want to kind of call it, it's one of the most prolific, known for its prolific Indian film industry, and it's also a financial powerhouse in India and fashion epicenter. Now, from there, I was just a regular school going kid. I think I had led a very carefree life and would eagerly look up to vacations, like every school student would. So for me, my vacations were like going back to my hometown, which is Kerala, and it's a South Indian, I would say, state, which is a very serene and beautiful state known for its famous backwaters. And for me, Kerala was mainly a world away from the frenzy of Bombay, where as if like you can kind of see that India has passed through a looking glass and come to a altogether more laid back place. I think that's, if there is one thing, I would define my childhood as utter bliss. Like I think that's the most blissful period of everyone's life. Now, in terms of career wise, my parents were both are maths and physics professors, and I'm not sure whether it's my ability or in my genes, but I had a natural inclination to go to that direction. And with that being said, I completed my bachelor's in engineering, electrical computer engineering in Bombay, and I had an appetite for looking forward in terms of researching more in that domain. Though I secured a job then, but I thought of kind of navigating and learning more in that domain, and that kind of pursued me to go into the direction of pursuing a master's. And that's where I came to Buffalo. So from Bombay to Buffalo, I did my master's at Buffalo, concentrating on signal processing. So that was my main domain. And I think my career goals have led me to a conclusion that it is always, I always try to get a better understanding of my field. And I think having done that, you're able to indulge myself in research. And I think that was the most awakening phase of my life, like at least my PhD and my master's phase. I was able to learn a lot of stuff, open a lot of avenues, and that's where I felt like I wanted to try different topics and see which is the one that I want to be concentrating my next 20 years of my life there. So when I was doing my master's at Buffalo, I was mainly focusing on communication signal processing, that area. And I think, as I said, that was like most enriching phase. And then I wanted to explore more. I mean, I think the quest for learning never ends. So that kind of pursued me to go forward with pursuing another degree, wherein I moved to Delaware, where I was doing my PhD in a similar domain, where I was working on the thesis that I mentioned. I was looking at developing deep learning algorithms for computer vision applications like wearable sensors. But it's not that I came to it on one moment. It is like a whole career path. So from the time I started my PhD, if you all know, you have your qualifiers, then you kind of figure out what's the area of interest that you want to do. You have your couple of internships. Those all those moments helped me to find the area that I was personally interested in, and I think I found that area where I was naturally inclined to develop new things for computer vision applications, and that interested me, and that's how I moved into the field of computer vision and machine learning. And then later I carved my path where I was more intrigued by how can I develop new machine learning or deep learning algorithms, and that can be applied to many areas. And now I see that I apply that for security, finance, many areas that this could be applied. So next slide. So this kind of caters my entire journey, where I started off from, I would say, a city of dreams from Bombay, and I'm landing now at California, which is the golden city. So that's kind of navigate. That's where I am right now. I'm a principal scientist here, but I think the quest to learn more has driven me to reach wherever I am, and I think I continue to do that. So in terms of my next slide, you could see my career timeline, like what I have done. So what I wanted to enumerate here is like it's not like a straightforward path. You have hiccups throughout your career. So I started off, as I said, in Bombay. I finished my engineering there, and I finished my master's. Next step at sunny Buffalo, where I was doing my master's specifically in signal processing and wireless communication. Post that, I wanted to kind of try understand like what is it that I wanted to kind of nurture, and I had an inclination in that area of signal processing, and I was an assistant professor for a year or so, it or two rather, and then I decided to pursue my career in terms of PhD. And I think that was one of the breaking points where I realized what is the area of interest that I want to take forward. And during my PhD thesis or PhD whole journey, I did a couple of internships at Canon and Intel, and that actually gave me a foresight into see how things actually work in industry. You see how they develop features or products and how they are being integrated into, from an academic direction, you're looking at solving a problem. You have your papers, then you have the patents, everything filed. But coming up to industry, I think I have a next slide which is kind of going over the lessons learned. But I think that part of exposure of getting that internships helped me understand like how is it different being in academia and how is it different being in industry. So post that, I was part of Intel, and I think I was doing my excellent internship. I was there during my internship, and I finished my thesis during that period, and I joined Intel as a full-time research scientist then. And I was part of Intel Security, which is now McAfee, where I was mainly looking at how I would say deep learning algorithms could be applied for cybersecurity problems, and that's where I mainly focused on developing threats or detecting threats like deepfakes. You must have seen those Tom Cruise videos where you have completely natural looking fake videos being created, and how can you use those technology to detect those kind of frameworks. So post that, I think I am now currently a principal research scientist at US Bank, where I'm looking in the same area of deep learning and machine learning and applying it for the financial domain. Going on to the next slide, I wanted to share a few things. I think at least lessons that I have learned from my career. One thing I would kind of focus on is you guys are all very early in your career, so always focus on your passion. Like you get excited thinking about what a business does or an industry does. This is important. If you're not excited about the potential impacts of your work, you might not be passionate about the industry. This kind of passion helps you to drive through the more monotonous part of your job. You might be helping your customers if you're working in a security field or any other domain. That being said, many companies are inventing solutions that solve the problems using their products. So I think understanding that what is the area that you like, or where do you want you use, what's the role that is apt for you, or where do you see yourself fit, that makes a huge number of difference. Next, I think always keep learning. That's something I think technology is always changing, right? When I started off with my PhD, AI wasn't like the big thing then. This was in 2012. Now, like people are into data science and full-fledged pipeline there. So I think technology is always changing. It will, and you are going to always have to work to stay on top of that field, be it latest trends or innovations. So one thing you can do there is attend training regularly, and IEEE-CIS has been a great platform for that. You can do like regular training as part of your job, and take every learning opportunity that even your employer offers you, and do not be afraid to do any kind of research and take part. Take some part of your career to invest some time in your own development. So you can research courses, read all the industry information that you get in hand, listen to people around you. There's something I wish I knew that earlier in my career. People around you are a gold mine of learning new skills, but if you have the time to listen to them, talk to your bosses, talk to your peers and ask them questions, talk to your co-workers. They might have insights that you might not. So those are the few things which I think actually enlightened me throughout my life, and I still continue to do so, and I will highly recommend that for others. Next thing is seeing failure as a growth opportunity. Now, this is, I think, common in both in industry and academia. There are going to be points where you have setbacks or you're going to make mistakes. Now, making mistakes is okay. No one is, good at doing something first time. These mistakes or whatever setbacks happen, they do not define you. It's I would say a reaction to those mistakes that define your success, or how do you react to something like a setback, and how does that set you forward in your career. So I know people say this, that you should always see failure as an opportunity, but one thing I realize is a failure will helps you always figure out what is it that failed for you and what is it that would work. So every time you fail, you learn a valuable information that whatever you tried did not work, right? So whenever you fail, you become better at it and you know a little more than you did before. So finding that information always helps, and that is something you are going to see it throughout your career, be it in industry or academia. That definitely happens. Next, I think don't forget to enjoy your success. That's, I think, being a paper acceptance. I think first paper acceptance while part of your PhD, I think it's a big accomplishment. So be it those small things, or even getting the biggest grade, I mean highest grade in your course. I think those small moments help you. You're adding a ton of value, not just while you're inspired as a student, but say in academia you have you have developed a paper which got accepted at the top conference. It's a big achievement for you. And even in industry, you have developed a prototype which gets released, or I mean it's like one of your forefront products. Those things, they are adding value to the company. So it's kind of worth taking that time and recognizing that success within yourself. Next thing, I think I personally do that is prioritizing what is important. Like, I think tech is a fast paced environment and companies compete rigorously, right? So regardless of your function, you are expected to contribute at a high level. As you grow forward in your career, you will quickly learn as to what to prioritize next. There are different ways to rank your project, define them. But I think make sure that time management is something that you always have as a big skill in your toolkit at any stage of your career. So that's something helps. Last one but not the least, always build a support group. Like, I'm not talking about a network, but a support group. Find some people who I think I have this set of people who I always go by when I have setbacks, or I have issues when I don't know what needs to be done in terms of career path. So there are people who you can find, people who from whom you can learn more about your role, who is willing to share their experience in terms of their career. And this does not have to be in your domain. There are people who have an experience from a different domain. They actually help you learn strategically how the same problem can be solved in a different way. So the easiest way is to make friends in different areas so that you can understand their pain points, and hopefully you too can return that favor. And I personally feel that, like, I have a mentor for a couple of, I mean, new junior engineers in my company. But with that being said, that functional or a support group always helps you to grow better in your career. Next slide. So this one is more, I think, in the leadership principle side. So now I think if you're in a phase where you're early in your career, I think the lessons that I've learned from my career, had I kind of thought about them very early in my career, that would have helped me even better, I feel. And I think this is something that might help you. So once you are in that phase when you're in an industry, people now look at leaders, right? What is it defines a successful leader? I think that there is a very great book. I have the list of books in my slides, but I think there's a very great book which I think which everyone should read. Like, even if you are not looking to be a leader, or these are the 5 traits which I think every leader as must have. So one is like inspiring a shared vision. Like, if you look up to someone, leaders who are driven by their clear image of their possibility or what their organizations can be, they inspire a shared vision by envisioning the future or enlisting other things in common. So this is like kind of looking up to a person and saying, hey, this is my leader, does he have those skills? Or where is it that if I want to become a leader in that phase, what is it that I feel that I am not fulfilling and where I need to work on? So this is what I'm trying to say with these leadership principles. Next thing is someone who can model the way. I think the most important personal quality which people look or even admire in a leader is a personal credibility, right? So credibility is, I think, the foundation of leadership. If a person does not believe in the message, or does not believe in the messenger, rather, they will not believe the message that you're providing. It might be granted, but I think leadership is basically earned. That's what I consider it as. Someone who is like challenging the process. This is kind of imperative for all, I guess, innovators, people who are working in that domain. Leaders are pioneers. They are willing to step out into the unknown. So I mean, the aim is to change, and the status quo is sometimes unacceptable. Now you look for opportunities to grow, innovate, and if you are always in a state of mind where you are just accepting and not challenging the process, maybe that might not help you as a person also to go to the next level. So that's something I think it's important. And these three things are core, and you might have these skills. Like, I think everyone has that flair for developing and challenging the process, but there are a few soft skills also that I think people do develop or need to develop when they are in the leadership principle path. The next one is encouraging the heart, or even enabling others to act. Now, enabling others to act, I would say, is making people more informed and connected. I would say exemplary leaders use their power in service to enable others to act, not by holding the power they have, but by giving it away. When people have more discretion, I think more authority, more information, they are more likely to use their energies to provide extraordinary results. And next thing is encourage the hard. I think I always feel that's very, very important. The climb to the top is extremely arduous and long, and people can become exhausted, frustrated, or even disenchanted, right? So they're all always tempted to give up. And as a leader, I think a best leader is someone who can always encourage your heart, recognize the, I would say, the contributions that you do, and celebrate your wins, like celebrate your small wins, whatever you have, and victories. And these genuine acts of caring can not only uplift the spirit but draw people as more caring, and it's kind of the heart of leadership. I think this is something I wanted to kind of pass on. Might not be helpful very early on in your career, but definitely give that book a read. And I think I learned a lot from that phase in my career. So next slide, please. So these are the few book recommendations if you guys would like, or anyone, right, would like to read on. I think I personally have learned a lot from these ones. If I have to pick, I would say two of these five. I would pick The Atomic Habits and The Leadership Challenge. The Leadership Challenge is the one, I think it's like the gold standard manual for building effective leaders. It's not something like you're looking to become a manager or something like that. Leader is someone who is someone presenting like a lead for that particular area. So the leadership challenge is all you need to identify and create leaders. So it's, people always say that it's not something that comes naturally, but looking at that book and even reading that book, you will realize that what are the checkpoints that I don't meet, and where is it that I need to develop. And I am personally doing that. I have those 5 bullet points written up in my book, and I know where I ask my mentors, I ask my mentees as well, where do they think I fall back, and then I try to spend the next year of my life to concentrate on that particular skill to improve it. The next one is on atomic habits. I think this book is great. It will make you learn to make small changes that will transform your habits. One thing you realize is, if you want to break into a big thing, or small changes make a big change in your life. Like, you are not going to reach a target in one day. That will never happens. So this book especially, like, they have a lot of, I think, evidence based strategies where they present as to how you can make small changes, or that can help you transform your habits and deliver excellent, I would say, result. That's another one. Thinking slow, basically it's mainly talking about, if you are people are usually prone to thinking fast, the path to least resistance. I think laziness is kind of built deep in our nature, right? So thinking slow affects our bodies, but how does that help you become a better, I would say, person as well? And the first one is, the courage to be disliked. This is, I would say, more philosophical, but it will guide you to the concept of self-care, and even self-forgiveness, and mind decluttering. So I think it's a very deeply liberating book if you have the time, but definitely give those ones a read if you have some time. Last one, not the least, for all the ladies, or all the women in this community. Lady, you're not a man. Definitely, it's a must read for all the women who are in the quest of finding, that apt home balance, and who are determined to success in their career, or want to find a very happy, fulfilling life. So these are a few book recommendations I wanted to share with everyone, and definitely give it a read. And I'm happy to answer questions with that. Next slide, please. So, thank you, first of all, for attending. My decisions and how I feel personally have been all shaped from my life experience. One thing I think I define that defines me is I think I have this natural flair of learning more. That quest to know more has always been there, and I love to learn. I get excited about new things. I sign up for more online courses that I actually can listen to. So I tend to I tend to love watch people, doing great things and learn new concepts. Definitely excites me. So all these conferences, being part of these conferences talks always helps me. So yeah, so I'm honored and humbled to be here, and I'm looking forward to learn what life has to offer me. But lastly, I must say I'm aiming to find more meaning in my life from my work as well. So hopefully this helps a bit. Thank you. Yeah.
Thank you both very much. I see Nancy Osen has joined us on screen, and I know we have a number of questions in the chat and in the Q&A, so we can get to those in the last few minutes we have together.
So yeah, a lot of really great questions because a lot of tremendous information. I mean, computational intelligence, they're really big words. So thank you for doing such a great job breaking them down. And I thought it was interesting that, Sharon, you work at a bank. People don't always think as engineers working in banks. And I think there's a message here for people studying computer science engineering about, really the career opportunities are in lots of places, maybe not necessarily where you think of them. So one person did ask us, how necessary is it to have a PhD to work in the areas that both of you work in? PhD or not PhD?
I would say that it's not necessary for the field I'm in. I would say that a master's would probably be about the level of technical ability that I'm using. What I've found is that it introduces a source of credibility whenever we're talking to people, whenever we're having discussions with people that have been in the field for years, especially in the behavioral science side. It's a very research-heavy group, and so they want to make sure that if they're talking to somebody that's in this world, that they understand people data, that they understand that the implications of poorly processing that type of data. It introduces a level of trust there as well.
I think I would like to add on this. So depending on what kind of role are you going into, right? If you are looking into the research scientist domain where you are looking into developing new algorithms, I think that genre, or I think that experience of going through that process of PhD helps you to get that mindset of, solving a problem, coming up with papers, that whole experience helps. But if you're looking into going into production or developing features for like building an ML pipeline, I don't think that's where you need specifically a PhD, but definitely that's it. It's very dependent on what kind of career path you're looking to achieve. So I think my personal take on why I did PhD was I personally had a long-term career goal of trying to improve or get more knowledge in that domain, and I think spending that 5 years helped me become stronger not only as a person, but I had a broad overview of that area as such. So being able, I mean, I feel personally, maybe I might not have that capability of writing papers or getting that understanding better. That helped me definitely in the PhD. So if you're looking for a data scientist job, or even looking for where you're trying to build platforms, I don't think you might end up needing that kind of core insight, but definitely you definitely need the basics of ML frameworks. Yeah.
That's great. Thank you. Another question, and this is one that, because we really appreciate the Computational Intelligence Society coming and working with EduCap. And we really think at EduCap, one of the things I've been working on is how do we get people more involved with one of our best assets at IEEE are technical societies. So this question says, you mentioned how beneficial it is being part of CIS because of the connections you've made. Are there opportunities for mentorships if you're a part of the society? Does CIS have a mentorship program or?
I'm not aware of that though.
Yeah, I would say
again, I think, maybe the connections, because I know, Bryce, you talked a lot about the connections. I mean, the people you meet are the people that you probably want in your universe, your network, if you would, of people that will maybe help you in so many ways that you can't even imagine where they could lead you to.
Well, there's two ways.
Go ahead.
Oh, sorry, Dad. Oh, there's two ways that I found really impactful is through my academic career with IEEE, and that was one was going to the conferences because that's a good way to meet people. Actually, I'm gonna make it three ways. Another one is to write papers. Write papers with people that aren't in your network. And so on like kind of the second layer of our network, I had some co-authors that they offered objective feedback that sometimes hurt really bad. But they made the paper better, and now like I knew I could trust them if I have a problem that I'm wanting a real answer on to make it better. And then the third one is actually going to be reviewing papers. And so this is advice that I wasn't expecting to get at the last conference I went to. They said, you know what, if you're not quite there yet, start reviewing papers, just getting in the rhythm of what that means, and you start to learn what's going on in the field right now, so that you're staying relevant, but you're also able to think critically about what the paper is doing. That way, as you're building out your own papers, your own work, then you can have that extra level of competence.
Great, thank you. And Sharon, you want to say?
Yeah, I think
something?
just to add on, I also feel that I found the best mentors as well at conferences, like meeting people with similar mindset and trying to learn more from them. That helps. Additionally, like I mean, it is better that you find your mentor in the sense that you find the area that you are looking to advance. That's something you should know before you go to a mentor and trying to ask help me, right? So finding that niche as to finding, hey, this is maybe strategy. I am not good at strategy. I want to develop myself there. Trying to find a person who is better than you in there and who can help you there. Trying to do that always helps. And additionally, like with CIS, I have attended like IEEE conference-based meeting where I have met people who have helped me reach where I am right now. So
yeah, I think that's a really strong message. I mean, engineering and success is about more than, and Bryce, you said it very well too, is more about what maybe your technical knowledge is. It's about all of these other things and those leadership skills. And you mentioned them too, Sharon. I think, we develop these leadership skills in places like IEEE and in IEEE, assuming leadership roles, working on groups. So the Computational Intelligence Society has a booth. So if you want to learn more about the Computational Intelligence Society, or there's like 7 technical societies here with us at this conference. I really encourage everyone to go pop over in the booth. There'll be either representatives there or links or things you can do, because again, I would want to network and hook up professionally to talk about opportunities with either of you all. You both have such great advice and meaningful things. We really want to thank you for taking the time to be with us today. We want to thank the Computational Intelligence Society for being a sponsor of this event. And we hope that all of you will stick with us and go visit the booths. And, we've got another session coming up in about 10 minutes. And we'll see you over there. Thanks so much.
thank you.
Bye.
Bye-bye.
Next up, we have a session on with Texas Instruments and Southern California Edison. So we hope to see you over in that session. And immediately after that, we have the recruitment fair, where it's not businesses and recruiters, but as Nancy mentioned, it is where you can also meet with the people from our technical societies to learn more about how you can get involved and what opportunities those societies can have for you. Thank you.